In this question, electric field of a sphere of radius r is given to us and we are asked to calculate the total charge on this sphere. For example, this is our sphere of radius r and suppose it contains volume charge density rho and total charge on it is suppose q. We will set our coordinate axis as, suppose this is our x-axis, this is y and this is z-axis. Electric field in the problem is given as E is equal to E naught z square times z unit vector. That is, this electric field is in the direction of z-axis. For calculation of total charge on this sphere, first we will calculate the volume charge density rho, and rho can be calculated by using the differential form of Gauss's law as del dot E is equal to rho over epsilon naught. Here epsilon naught is the permittivity of free space and del is the usual differential operator. We will write it in the following form, that is rho is equal to epsilon naught times del dot E. As electric field is only along z direction, so we can simply write this equation as epsilon naught times partial over partial z of E. And if we differentiate electric field with respect to z, then we get the following expression as our charge density rho is equal to 2 times epsilon naught E naught and z. Now if we integrate this volume charge density along volume element dv, we will get the total charge on the sphere, which is q, and using the value of rho here as 2 epsilon naught E naught z dv. Writing the constants outside the integral as 2 epsilon naught E naught, and now as we are dealing with sphere, so we will use spherical polar coordinates as r from limits are 0 to r, and the limit of theta is from 0 to pi, and the limits of phi is from 0 to 2 pi. Z in the spherical polar coordinates can be written as r cos theta, and volume element in spherical polar coordinates can be written as r square sin theta d theta d or d phi. In this integral we have product of sin theta and cos theta. If we multiply and divide it by 2, then we can write them as sin 2 theta, and as limits of theta is from 0 to pi, so when we solve this integral and put the limits of theta, we get this integral as 0, and when that 0 multiplied by other factors, then we get the whole answer as 0. So total charge on this sphere is 0, which is option E. So E is the correct option for this case.